So my topic for this session is unlocking new possibilities, leveraging specifically AWS generative AI for your organization. So again, welcome and thanks for taking the time to attend the session. In the next few 15 to 20 minutes or so, I'll walk through the following 4 items. What is Gen AI? Why it's relevant? How to go about implementing an enterprise-grade solution that incorporates the appropriate measures of the well-architected pillars, namely security, reliability, operational excellence, performance efficiency, sustainability, cost optimization, and additionally, especially in the context of Gen AI, principles of responsible AI. And in particular, I'll be referencing responsible AI throughout my presentation. And finally, I'll wrap it up with some representative use cases across a few select industries. So Gen AI, as has already been said here, is a type of AI that can create new, novel content, spanning conversations, stories, images, videos, and music. What makes these foundation models special, though, is that unlike traditional machine learning models, which typically are trained to perform a singular task, foundation models can perform many, many more tasks because they contain, as referenced earlier, a large number of parameters through their pre-training exposure to internet-scale data. Types of FM, typically I look at them in 3 categories: text-to-text, text-to-embeddings, multimodal. And multimodal is where you look at text-to-image, so for example, diffusion models. Capabilities of Gen AI, I typically club them into 4 broad categories, and the value you can derive is either individually through each category or more so by combining the categories together. So first category, summarizing. Here, as the name implies, you summarize user reviews, summarize artifacts. Additionally, and that's pretty cool here, if you want to do something for a specific purpose in mind for the summary, you can do that too. So you can generate a summary that's more applicable, for example, to a given group in your business, a given department. Additionally, you can also summarize with a specific focus in mind, focus on price, focus on value. Next category, inferencing. So what this relates to here is basically performing some kind of analysis. So this could be extracting topics, labels, names, etc. Extracting sentiments. And then once you've got those sentiments, then combining those sentiments, i.e. breadcrumbing them per se, to create emotions from them. Transforming. And what I mean out here is kind of translation between languages, for example, a particular English to Spanish, or even translation between languages, Java to Python. And then also translating across formats. So translating from, for example, JSON to HTML or the other way around. Tone adjustments, format conversions, spelling and grammar correction. In fact, if you want to proofread your text, you can do so by telling the LLM or foundation model through a prompt, proofread or proofread and correct. Expanding. So now that we've looked at these 3 different categories, let's look at the 4th category, where we can expand, i.e. extract or create automatically, write content like emails, artifacts, etc. And you can do that, like I said, in isolation, or better still, by combining the categories. So for example, having already extracted the sentiment, you can generate emails that are tailored to each customer's review. I also wanted to touch upon out here on a specific hyperparameter called temperature that will allow you to change the variety of the model's responses from, say, more deterministic to less deterministic. So for example, you can think of a temperature as the degree of exploration or the randomness that you want to inject in your content. Lower the temperature, more deterministic; higher the temperature, less deterministic. So I wanted to spend some time on the AWS Gen AI strategy, specifically its differentiators and the unique value proposition built on the foundational theme of democratizing AI for organizations of any size. The diagram on the left, you may have seen some earlier iterations of this. It had 3 pillars, i.e. Bedrock, the custom chips, Code Whisperer. More recently, a 4th pillar has been added to it, i.e. the SageMaker Jumpstart, the SageMaker Hub. So let's look at the features on the right that really contribute to why we are so excited about the AWS Gen AI strategy. Flexibility, allowing you to choose from the broadest choice of models, proprietary and open source, from leading AI startups and Amazon, to suit your unique business requirements, i.e., again, in Amazon terminology, working backwards from your requirements, specifically helping you choose the model that satisfies your needs across non-functional requirements such as accuracy, cost, and latency. So from Bedrock, a managed service, you can choose from a variety of models from companies like AI21, i.e. the Jurassic Labs family, Anthropic Claude, Stability AI, Amazon Titan, and the newly added Cohere model family. And from SageMaker Hub Jumpstart, if you prefer a more customized under-the-hood paradigm, you have access to additional models, including a wide variety of models through Hugging Face and others. Secure customization, really, really important, because all the data in this case here is encrypted and doesn't leave your VPC, i.e. the virtual private cloud. You can trust that your data will be private and confidential. Additionally, it also protects the model provider's IP. Model packages and endpoints are hosted in SageMaker-owned escrow accounts. Containers also have no outbound network access. The most cost-effective infrastructure. So Amazon AWS Trainium and AWS Inferentia, both version 1 and version 2 chips, offer the lowest cost for training models and running inference in comparison to other EC2 instance families. Additionally, organizations continue to have the flexibility, though, to leverage ML infrastructure powered by, say, NVIDIA GPUs and AWS design chips to achieve the optimal infrastructure that will maximize profits while, of course, controlling costs. Generative AI-powered solutions. So out-of-the-box services like Amazon Code Whisperer, which is an AI coding companion, can help you to improve productivity. In fact, as referenced earlier, in a productivity challenge, participants who use Amazon Code Whisperer were 27% more likely to complete tasks successfully. And not just that, they did so 57% faster. Other reasons that I'm really excited about Code Whisperer are its code responsibility adherence, i.e. things like reference tracker for open source and bias avoidance. So Code Whisperer helps developers avoid bias by filtering out code suggestions that might be considered biased or unfair. Features that are dedicated to helping with the responsible use of AI and ML technologies. In addition, around these AI-powered solutions, you can deploy generative AI use cases like call summarization, question answers, using these AWS sample solutions that combine AWS AI services with leading foundation models. So I've been a part of Bedrock Preview for some time, and again, pretty impressed with it and wanted to touch upon a few of its capabilities, including the most recently released feature, custom models. So Amazon Bedrock, to iterate from the previous slide, is a fully managed service, a serverless, fully managed service that makes foundation models from leading AI and Amazon available to you via an API to find the model that's best suited for your specific use case. With the Bedrock serverless experience, you can get started really quickly, privately, and this is important, privately customize foundation models with your own data. Again, I repeat, you can privately customize foundation models with your own data and easily integrate and deploy foundation models into your applications using already familiar AWS tools and capabilities, such as integration with, say, SageMaker experiments to test different models, SageMaker pipelines to manage your foundation model at scale. So Amazon Titan, haven't spoken about that a lot. Let's speak about that now. That is a foundation model from Amazon. It consists of two basic categories. The first one is Titan Text, which is a generative LLM for tasks that span the four broad categories I referenced earlier: summarization, inferencing, so information extraction, classification, text generation, creating a blog post, for example. The second one, and this is pretty interesting here, is Titan Embeddings, an LLM that translates text inputs into numerical representations known as embeddings that contain the semantic meaning of the text. It's really useful for applications like personalization, search, even Q&A techniques like RAG, which stands for Retrieval Augmented Generation, something I'll touch upon in the next slide. Because by comparing these embeddings, the model will produce more relevant, more contextual response than, say, just the normal lexical or even basic semantic matching itself. Finally, to continue with the theme of responsible AI, Amazon Titan FMs are built to detect and remove harmful content in the data, reject inappropriate content in the user input, and filter those output that may contain inappropriate content such as hate, speech, profanity, and violence. In turn, helping the solution adhere to the three H's. The three H's that I typically refer to are helpful, i.e. is the solution helpful? Is the solution harmless? Is the solution honest? So out here are basically generative AI building blocks, the ones that you typically will go through as you kind of sift through the hype and try to deploy an application in an enterprise. Precursor, of course, to all of this here is the working backwards from the customer, i.e. identifying the appropriate use case opportunity, either one or many, to leverage generative AI to deliver business value. Next step is selecting the right model. Since there is not one model to rule them all, there are hundreds of models and new ones seem to be popping up at an amazing rate. Leveraging the wide variety of foundation models provided by AWS and tapping into leaderboards like the ones from Hugging Face, for example, or Helm, which stands for Holistic Evaluation of Language Models from Stanford, and working across the three tenets like I mentioned before, the ones being accuracy, cost, and latency, will help you in expediting the model selection process. The next step is training. Why do you need to do that here? So typically you want to customize the foundation models to create unique customer experiences that embody your company's voice, style, services across a wide variety of industries. Additionally, it also helps to reduce hallucination. Now, there are various techniques here to do this model fine-tuning or model training rather, techniques that vary in complexity across and even within individual mechanisms. So starting with the simplest one, prompt engineering, and within it, again, a fairly simple one, i.e. zero-shot learning, which is basically a data-free approach to learning because it requires no examples, just tweaking or tuning the prompt. Then as you get a bit more mature, to improve the odds of having the model produce what you're looking for, you can provide one or more examples in what's called one-shot or few-shot learning. But no matter how powerful these techniques are, they'll get you only so far. And the reason they do that is because when you try to create these prompts aren't really portable from one LLM to another. Something that works beautifully in one may not work as well in the other. The other thing, of course, is when you want to customize these on your own company data, on your own proprietary data. And of course, you want to prevent leakages from happening, number one, but more so, these prompts with these LLMs have a kind of limitation on the token, so you can't really push in huge amount of data. So what's next? Then you get, through your maturity into fine tuning. And again, like I said before, there are various levels of gradation even within a given technique. So you can start off first with instruction-based fine tuning. This involves training the foundation models to complete a specific task. So it takes fewer data sets, obviously, and steps to train the model using a labeled data set of prompts and responses. In this case, what you're doing is you're basically updating the model weights, but you're updating it based on a task or a layer that you're fine-tuning. While this is all great, you do need to ensure that you account for something called catastrophic forgetting, wherein since the weights have been changed, there is a possibility that prior knowledge that the other layers had is no longer intact. Then you move into something called domain adaptation, which is also kind of referred to as further pre-training. And this training is more broad, more extensive, as compared to what we talked about, which is task-based, instruction-based tuning. So this techniques kind of involves feeding the model a large amount of information of domain-specific unlabeled data, like you may have seen from Bloomberg when it created the Bloomberg GPT. Domain-specific jargon, statistical data that the existing foundation model may not have seen before. So once you've done this, obviously you want to do some evaluation. You want to make sure the quality of the model is good. And for that, you can have, again, various mechanisms to do that, things like reinforcement learning with human feedback, or you can even have a model, again, look at the output of the previous model, what's now called reinforcement learning through AI feedback. And of course, evaluation metrics like Rouge, NLS, Blue, so on and so forth. One other thing I wanted to talk about here is now that you've got this model and you think it's cool and all that here, now before deploying, you need to optimize the model. And optimization includes things like compression, pruning, distillation, quantization, and some other mechanisms. Then now that the model is there, hey, now you want to integrate the model so that it's useful and relevant and people can use it. And let's talk about RAG, which I talked about earlier, which is retrieval augmented generation. So what this is, and has been referenced in the example earlier, is kind of a closed domain knowledge of proprietary data that you have. It goes through a text embedding process to generate vector representations of the data set, and that's stored in a vector database. Could be, for example, Amazon Titan or some other systems that you want to use in this case. Then when the user puts in a query, that query is further embedded. Again, create an embedding of that. It's matched again what you have in your vector database. The results, which is a collection of outputs, including the query, is then given to an LLM as a prompt, and the LLM then is used to generate a response, a more contextual response, a more conversational response with the information that you fed it. In this technique here, one thing to remember is that the foundation model itself, its weights are not updated. The next thing out here is once you've done this here, then of course you want to expose this information to your users. And you can do that through different UX tools like Streamlit, Gradio, so on and so forth. Also, there's a kind of a really cool technique called React, where what you're trying to do is, React stands for reasoning and action. And what you're doing out here is you're actually using the reasoning power of the foundation model rather than just information retrieval. And so what you do out there is basically you give it a text, the foundation model does some reasoning, then does some action, and then there's an observation, the observation being the output of the action. And in this case, you typically will try to, combine different components together to produce the right output. And that's where you'll end up using things like potentially LangChain, or even start using things like agents, which was a new feature that was announced for Bedrock at the New York Summit in the July timeframe. What I'll do next here is very quickly, I think running short on time, but I'll very quickly go through, some of these use cases that I've depicted across a variety of industries. So again, since running out of time, I'll skim through this. Of course, you guys have the slides here, so you can definitely reach out to me. What I did out here was, took the industry, took some subsegments of the industry and specific use cases, including these use cases that are now live in production across some of the companies within these industries and industry subsegments. So this one is for retail and consumer goods. This one is for healthcare. I tried to kind of, narrow it down across the 3 Ps, so the provider, payer, and the patient paradigm. And of course, some specific examples out here are things like prior authorization, which we know is a big pain here and can really benefit from generative AI. Also, clinical domain-specific summarization tasks can also definitely benefit from Gen AI. Financial services, again, try to break it down into different subsegments and use cases out here. And then media and communication, and this covers a broad array of things like gaming companies, things like telcos, so on and so forth. And of course, there are live examples out here of Omicron, for example, that's using AWS Gen AI to help accelerate the transformation of advertising, campaign development, LG AI research, which used SageMaker to create something called Hexacon, which was then used to create outfits for the 2022 New York Fashion Week. And a bunch of others here, including the ones in gaming, for example, Ubisoft, AI21, so on and so forth. But finally, again, trying to wrap this up in time, wanted to leave you with a few of our offerings, including the Gen AI enterprise use case, business value opportunity assessment, wherein we work backwards from the customer and use that in conjunction with the deep dive into their data, identify and validating the growth areas and opportunities, and create a well-defined roadmap that outlines the implementation of use case using clear, actionable insights. And with that, thanks again for your time.